Control flow is an essential aspect of any programming language. In this and the next lesson we discuss loops and conditionals. We start with conditionals. Conditionals are used to determine which code needs to be executed when. Swift defines three constructs: if statements, guard statements, and switch statements. We've already encountered a few if statements in this series. The if statement is easy to understand and requires little explanation. In this example, we execute the showLoginView function if the value of isUserLoggedIn is equal to false. Unlike C and Objective-C, there's no need to wrap the condition in parentheses. However, the body of the if clause should always be wrapped in a pair of curly braces. And that's a good thing, since it avoids common bugs and promotes consistency. Swift's if statement also supports an else clause and chaining of if statements. If the value of isUserLoggedIn is equal to true, we check if the user has started a trial membership. If she has, we show her a list of payment plans. If she already has a paid membership, we take her to her dashboard. Even though the if statement is great and indispensable in every application, complex application logic often leads to nested if statements. Nesting isn't a problem in and of itself, but it can result in hard to understand code if it gets out of hand. This is especially true when using if statements in combination with optional binding. This example is a bit contrived, but it shows the problem of nesting multiple if statements. The fetchSales function fetches the sales for a user. It returns false if it cannot perform the API request. Before we can send a request to the API, we need to make sure we have access to the current user, and that the user is logged in. We need to plow through 3 if statements before we can make the API request. I think we can do better. We can greatly simplify the fetchSales function by replacing the if statements with guard statements. This is what the implementation of the fetchSales function looks like with guard statements. A guard statement is similar to an if statement. The key differences are that a guard statement always has an else clause, and that variables and constants assigned using optional binding are available in the scope the guard statement was defined in. That's why the URL variable is available to us after the third guard statement. Another key difference with Swift's if statement is that the else clause of the guard statement needs to transfer control. What does that mean? The guard statement is designed for one purpose: exiting early. The refactored implementation of the fetchSales function illustrates this. The application returns from the function as soon as it knows the request cannot be sent to the API. It does this by transferring control in the else clause, exiting the function in this example. If we don't transfer control in the else clause, the compiler throws an error. The compiler warns us that we need to exit the scope in which the guard statement is defined, for example by returning from the function. The guard statement is a wonderful addition to the Swift language. It helps you keep your code readable and easy to understand by keeping nested if statements to a minimum. Swift's switch statement is incredibly powerful and versatile, and that isn't an exaggeration. The basic syntax looks like this. In the example, we switch on the value stored in status code. We start the switch statement with a switch keyword, followed by the variable or constant whose value is evaluated by the switch statement. The cases of the switch statement are wrapped in a pair of curly braces. Swift's switch statement behaves quite differently from that in other programming languages. In Swift, switch statements need to be exhaustive. This means that every possible value of the type that's being evaluated needs to have a corresponding case in the switch statement. Because it isn't possible to add a case for every possible value of an integer, the type of status code, we add a default case. The body of the default case is executed if no other match was found. This brings us to another difference. The body of every case needs to have at least one statement. That's why we add a break statement to the default case. The body of the default case cannot be empty. If you're coming from C or Objective-C, then you may be wondering why we don't add break statements to each case. Remember that Swift is obsessed with safety. For switch statements, that means there's no implicit fall-through. As soon as a match is found, the switch statement is exited. While this may be safe, it leads to code duplication. What do you do if multiple cases need to execute the same code? Don't worry, Swift has you covered. In this example, we switch on the value of name. Notice that the first case defines 3 patterns instead of 1. The patterns are separated by commas. We could also write the above example like this, putting each pattern on a separate line to improve readability. The switch statement in C and Objective-C is quite limited in terms of what you can do with it. In Swift, the type you switch on isn't limited to integers. In this example, we switch on a string. But it doesn't stop here. Swift's switch statement also supports pattern and interval matching. In this example, we use the half-open range operator to evaluate the status code of a network request. Did I mention that Swift's switch statement also supports tuples? The syntax is what you'd expect. We define a tuple employee with 3 values. We evaluate the value stored in employee using a switch statement. The first case is a match if the value of seniority is greater than 5 and less or equal to 100. Are you confused by the underscores in the example? The underscore character indicates that any value is a match. That's why the underscore character is also referred to as the wildcard character. The example also shows the use of the where keyword to define additional conditions for the case. The second case is a match if the employee has more than 2 skills listed in her profile. The second case also shows us value binding. We bind the values of the employee's skills in a temporary constant, skills. We can use the skills constant in the where clause, and it's also available in the body of the case. This is very convenient, especially when working with enumerations, which we discuss later in this series. I'm sure you agree that the if and guard statements are easy to use and understand. The switch statement may be a bit more daunting due to its amazing flexibility and versatility. In the next lesson, we continue exploring control flow in Swift by taking a look at loops. If you have any questions, leave them in the comments below or reach out to me on Twitter. And don't forget to subscribe if you want to learn more about Swift development and Cocoa development.